So here's what we're talking about today, gang. We're talking about when belt cleaning fundamentals fall short. The reason why I wanted to choose this topic is because I'm constantly taking calls about problems with carryback when they exceed the traditional belt cleaning methods that we've talked about for a long, long time. So that's why we're going to chat about that today. If you're struggling with some of the problems that we're going to talk about today, let us know, and we'll do our best to get one of our field agents out to take a look at that problem and give you some expertise advice on that. So here's what we're going to cover today. The first thing we're going to do is we need to review those traditional belt cleaning fundamentals. For some of you, this may not be new stuff. For some of you, it might be new. But pretty quickly, I'm going to just real quick talk about what we typically are going to first try to attempt when cleaning a belt. And then, secondly, we're going to discuss why those methods that we traditionally do might fall short. We're going to discover how to react to the problems when those methods do fall short. And then finally, we'll learn about some of the non traditional belt cleaning options that are on the market. So let's talk about this traditional belt cleaning method. If this is my head pulley, this is where we're going to focus our belt cleaning efforts at. And you've got to divide this head pulley up into a couple of zones. The first zone we would call the primary zone. And in the primary zone, you're usually going to eliminate only about 50% of the carryback. And the reason why you're not going to get all the carryback removed at the primary zone is because most of the time, not always, but most of the time, those primary belt cleaners are made of urethane or rubber. And the reason they're made out of urethane or rubber is because they're almost, not always, but almost always in what we call an aggressive angle. So this should look pretty familiar if you've used belt cleaners before. This angle right here is greater than 90 degrees. That causes an aggressive angle to the belt, and steel belt cleaners, metal tipped belt cleaners, can damage the belt or maybe even the splice if they're put at that aggressive angle. So they're almost always made of urethane. And that urethane, the pressure between the urethane blade and the rubber belt is such that it can only eliminate about 50% of that carryback. Now, in the secondary zone, we typically don't use that aggressive angle. We use a non aggressive angle, and that'll get us about another 40% of our carryback eliminated. And the reason why we're not going to use, the reason why we're going to use that non aggressive angle is because those blades are typically made of tungsten carbide, sometimes stainless steel, but some sort of steel. And they're installed if this belt's traveling this way. Those secondary cleaners are installed at a less than 90-degree angle. That less than 90-degree angle, that's non-aggressive. Therefore, in most cases, it's safe to put that tungsten carbide blade against the belt. This is that traditional belt cleaning method. Now, Martin Engineering's taught this. It's in our books. We've done classes for many, 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 many years, and it works in almost 99% of the applications. But that's not 100% of the applications. There are instances where these methods will fall short. But this is kind of our first recommendation. This is what we prefer. This is what we're going to recommend in almost every application. However, sometimes these methods can fall short. First is sometimes we won't get that 50% or 40% performance if they're not installed correctly or if they're not maintained correctly. And that's almost always the first thing that I look at when a belt cleaner, when I'm told a belt cleaner fails. Are they installed correctly, or are they being maintained? The second is oftentimes it's the wrong cleaner selected. The diameter of the pulley has huge implications on which cleaner you need to specify. And many, many, many times the cleaners are undersized for the pulley. When those belt cleaners are undersized for the size of the pulley, they're gonna fail. So you've got to make sure you get the right cleaner for the application. Third, these traditional belt cleaning methods, they can fail if you've got a belt that's in poor condition or a cleated belt. We'll talk more on that in a bit. Or if you've got a poor splice. So if you've got surface damage, like what you see in this photo, the carryback vibrates down into the crevices of that belt, and those belt cleaners can't get that carryback to lift out of those embedded cracks. So it's a very challenging situation. The other thing is the splice. We need to make sure that we have a good splice. Good splice is defined as uh, vulcanized. If it's not vulcanized, we can use mechanical clips, but they should be skived. And if they're not skived, we want to make sure we're using the right size clip for the belt. We want to make sure that our belt cleaners have some sort of shock ring in them to work with that splice. And we could grind the leading edge of that splice down. All right, now sometimes the material characteristics can be such that these traditional belt cleaners can't get it off the belt. So really, really sticky fines, really, really wet fines, they can be more problematic. And as your material changes, those belt cleaners might not be able to keep up. And then finally, a reason why non-traditional belt cleaners can fall short is because there's varying acceptable levels of carryback. Traditional belt cleaners, we expect to get about 90%. And in some cases, that's not sufficient. If that belt is returning over a roadway, maybe it's a port facility and there's waterways underneath the belt, or you're in an environmentally sensitive location, or it's just very challenging to clean up the material. In those cases, you might want a better performing setup that will get more than 90%. So, what do we do when these traditional methods fall short? How can we react? Let me give you some guidance on that. First thing you can do, and this is kind of the simplest, least expensive solution, is to add more cleaners. If you put a primary and a secondary and not get that 90%, it's common practice to add an additional secondary or multiple additional secondaries. Every time you scrape that belt, you're going to get more and more material off the belt. Now, if you look closely at this diagram, I purposely had this drawn to show you that the second secondary here is scraping less material than the first secondary, which is here. Now, that's pretty typical. The expectation is the more swipes that you take at the belt, the more material you'll get off that conveyor. Now, the problem with adding multiple secondaries is that it doesn't, the carryback that's scraped off of those, off the belt in those positions, it's difficult to return that material back to the flow of material. So I had included in this diagram for you what we call a vibrating dribble chute. So what happens with this vibrating dribble chute is there's a sheet of UHMW, that's right there. That UHMW is very slick. We also add a vibrator to the back side of that. It's held on with a bracket. As that material starts to build up on this chute, on the surface, the combination of that slick UHMW constantly being vibrated can return that material that's scraped off the belt into the flow of material. So that's kind of the cheapest, quickest, least cumbersome solution to what we might be dealing with. Now, I want to show you another option. These vibrating dribble chutes have been around a long time. A lot of people make them, and they're fine. Well, I shouldn't say they're fine. In some cases, they're not fine. In some cases, they don't. They can still build up with material. So we're in a unique opportunity because um, we manufacture air blasters. And in the last couple of years, we've been, rather than using vibrators on the backside of those chutes, we've added one of our smaller air blasters. And with our nozzle technology, we've designed nozzles that can shoot blasts of air out and down that sheet of UHMW and prevent material building up on that. So incredibly effective. Make sure that that thing doesn't build up with material, and that is working very, very well here in the last couple of years. Now there are some complex situations where you um, instances where people will design dribble chutes that return the material back. Sometimes they can be quite complex in a scavenger conveyor or things like that. And when you have something long like a scavenger conveyor, like what you see here, you can really start stacking in secondary cleaners. And it's not uncommon, especially like in coal mining, where they'll have a primary cleaner and then they'll have maybe 5 or 6 secondaries built, installed behind it, and then a scavenger conveyor similar to what you see here, moving that material back. However, there are more aggressive options than what we're showing here, and I want to chat a little bit about that. The probably the most aggressive option, most effective option when you are not getting the results that you want from the traditional methods is to use um, what we call a belt washing. Now, belt washing it's been around for a long time. It was pioneered by if you've ever heard of Dick Stahura was a pioneer in the mining industry and helped develop a ton of the material and concepts that Martin Engineering has executed to help operations clean their belts. But originally, there were three methods of washing a belt. There was they called the flood method, and the flood method was kind of like it sounds. It was basically just setting up some sort of spray system, and it might be as crude as having someone spray the belt down with a water hose. But it was just basically spraying a belt either with some sort of fixed equipment or with people. The flood method is kind of cumbersome. It's pretty dirty. It can be effective, but too costly to execute. The second method is the bath method. And the bath method is also just kind of like it sounds. The bath method was basically taking that belt and just returning it through a pan of water. So that belt would return back and it would drop down into a pan of water, and that pan of water could eliminate some of that carryback. Both of those methods now are pretty obsolete. I don't know of anybody that's doing any of those anymore. What's kind of the preferred method now is what we call the washbox method. And that's kind of what you see in this diagram. A washbox is a complex, multi component box that the belt enters dirty, packed with material, and exits clean and dry. So I want to show you a little bit better look at a washbox, a 2025 washbox, and kind of what it looks like. I'm going to show you this animation here, and you're going to see here. So this is on the top side, this is our belt. We're going to zero in on this washbox. You can see here that it's got a handle. This is an inspection door. We'll roll around to the opposite side here and have you take a look at this is where the water would come in. You can see this is a drain system at the bottom. We'll talk more about that. Inspection doors on this side. Now what I want to do is I want to break through. I want to I'm going to give you this internal view of this. So as I look down in it, you can kind of see the spray bars. I've taken the secondary cleaners out of here, but this will include secondary cleaners. More on that. And if I get here, you can see the high pressure nozzles here. So those high pressure nozzles will spray the belt, and they'll also spray the secondary cleaners that are typically included with this. And you can see these nozzles are pointed down. So there's nozzles included that will help clean out the box. You saw that drain at the bottom. There's that drain again. Again, there's a latch here. This is all sealed up, watertight. And that's a 2025 kind of state of the art wash box system. They're pretty impressive on how well they can clean a belt. I talked a little bit earlier about some of the multi components that are included. I want to talk more about that. All right, so the components of a wash box are important, and any wash box should include tungsten carbide secondary belt cleaners. That's the number one component, and I don't want to dismiss that, even though I didn't show it in that animation. I want to make sure that you understand that traditional secondary belt cleaners are the most important component of a wash box. You can't just spray that water on the belt and expect it to rinse off. You've got to scrape inside that belt as well. And that scraping follows the same secondary principles that we've always talked about. Should be at a non-aggressive angle, should be tungsten carbide, and should be tensioned properly, should have a hold down roll. All those traditional secondary concepts are applicable when cleaning inside of this wash box. Wash box should also include those high pressure water spray bars that we talked about. You should, in most cases, have some sort of water filtration. Typically, 10 mesh is sufficient. Number four, we do want to have a return roll, traditional return roll included in the wash box. And you can see just the leading edge of that included return roll. Now, the reason for that return roll is that you want to support the belt as it enters that box. You don't want that belt riding on the framework or the steel of that box. So if you're looking at um, wash boxes, you want to make sure that you select a wash box that has a return roller included. Most do, ours do, but there might be some out there that don't. Number five, you've got to have those hold down rolls to work in conjunction with your secondary. Number six, you want to make sure that you have inspection doors so workers, when locked out and tagged out, can access the inside of that box to maintain those belt scrapers. Those belt scrapers are, again, susceptible to the problems of any secondary cleaner. My concern is maintenance. If they're not maintained, they're not going to perform. So you've got to make sure that this wash box includes good access so workers, when locked out and tagged out, can get in there and inspect the blades and change out those secondary blades as needed. And then finally, number seven, they should include a squeegee cleaner like what you see here. Very early in the conversation, I said a wash box would have a belt dirty, enter, and would be clean. And if you recall, I said that belt should exit clean and dry. That's the importance of that squeegee belt cleaner. Now, we're in a unique situation where we make our own urethane, and we've developed a very, very low rigidity urethane. It's very, very flexible, and it really creates that squeegee effect, just like a slab of rubber that was really flexible at getting you to squeegee water off of a shop floor. This blade, with its flexibility, will squeegee that water off of the belt, having that belt exit clean and dry. Everything drains down through a bottom drain, and that's up how you manage that drained water and material. That's different strokes for different folks. Different facilities might let that just run down into waste. Sometimes some folks will let it settle into a box, pump off the water, reclaim the material. But it's just kind of different applications, and we can give you some guidance on what those options are if you're interested in some sort of washbox system. The problem with cleated belts, they're a big challenge. I take calls on this every week. What do I do with my cleated belt? How do I scrape it? Belt cleated belts are very challenging. They interfere with that smooth, flat surface that's so critical for traditional belt cleaning. So they create a challenge. They can still be cleaned. Don't feel like if you're using a cleated belt that you shouldn't make any effort to clean them. It can't be done. They can be cleaned. However, you've got to lower your expectations on how clean that belt can get. And you need to understand that to clean that belt, it's going to come with increased efforts, and that might come with increased cost of units to clean it. So they can be cleaned, not as well, and it's going to cost you more. But if you're cleaning up material underneath these belts and they're carrying back, what you need to do is weigh the cost of cleanup, the cost of the man hours, the cost of that lost material, the risk of injury that it's posing to the plant by having guys doing that work, and weigh that cost into the extra cost it might be to clean a belt like this. So there's two types of secondary belt cleaners out there, and they're designed to clean the two types of chevron belts that you'll find. There's V-shaped cleats and there's U-shaped cleats. A V-shaped cleat typically uses two belt scrapers, and each belt scraper is going to clean one side of that V. So the blades are set at an angle, and that angle with two units will eventually get into both sides of that V. Um, I'll show you more on that here in a minute. On U-shaped cleats, typically you just use one single unit like what you see on the right. And these can be there's kind of different ways to doing this, but in this case, there's very flexible slits in this blade, and that kind of gives that blade a fingered effect, and that helps get as much material off the belt as possible. I wanted to include this photo in the right. This is a good example of how you have to use two units, one unit with the blades in one angle, the second unit at the blades at the other angle to clean a belt that has the typical V cleat like what you see here. I don't know if there's any topic that I address more in my live classes, in our online classes, when we come on site to teach a class, or when we have a worker go through our online courses. I think brush cleaners almost always come up. And we got to talk a little bit about brush cleaners. There's lots of them on the market. Everybody makes them. We make them. Our competitors make them. There's guys making them in their garage. If you got some good millwrights, they're probably making them in your shop right now. And they sure seem like they should work. Conceptually, when you think about it, there's really no reason that they don't work. And I'm not going to tell you that they don't work, but I am going to tell you that there's some things that you need to take into consideration with brush cleaners, no matter who's making them. There's a couple of different styles. Okay, there's what you call a strip brush cleaner, which is shown on the left. More common is what we call the spiral brush cleaner, which is shown on the bottom right. Most of the time when you search brush cleaners online or Google it, you're going to find what is called the spiral brush cleaner. And the difference is in how the brushes are exposed to the belt. You can see the top one, it's spirally wrapped like a barber pole. And on the right, you just got the bunch of bristles popping out of this thing. Um, so here's my concerns with the brush cleaner. In our studies, our research, and we've researched this many years, but our research tells us that the max efficiency or effectiveness of a belt cleaner is that it's going to get about 40%. That's max. Now, if we compare that to earlier conversations, we said a primary and a secondary would get 90%. The max that we expect out of one brush cleaner is 40%. Now, if you add additional belt cleaners in there, you might get more than 40, but the max that we expect is 40%. That's a struggle. That's a concern that we have. You need to be aware of that. It's human nature. I think it's nothing more than human nature that maintenance staffs want to overtension brush cleaners. I think it's human nature that they want to overtension any belt scraper. And here's why I think it's human nature. If a belt brush is working, well, it should work better if we put more pressure on it. It's no different than sweeping a floor, gang. If I go out and sweep my garage floor and I get a tough spot, I'm going to give that more pressure. The concern with that more pressure, and I think you'll always have it, is those bristles are designed to deflect. Um, in most manufacturers of the brush are going to tell you that bristles shouldn't deflect any more than about a quarter of an inch. It beyond a quarter of an inch, those bristles are going to start to break, and that's concerning. Bristles breaking aren't a warranty issue, and that certainly could happen. One of the other problems that we have with brush cleaner is that they become ineffective if and when material builds up in them. So material can cake up into those brushes, and those become a lot more ineffective when that happens. And then the other issue that we have is that they're going to create some dust. So there's a motor attached to this thing. There's a spinning brush inside there that's going to pull air in. It's called induced air. It induces air into the system, and you're going to have to manage that air at the next point of trying to settle material. So if you're unfamiliar with how to control dust, I'll really ask you to refer to some of our previous webinars on dust control. And you need to recognize that when you add brush cleaners, you're increasing induced air. That's going to cause you some dust problems that you'll have to contend with. So brush cleaners are again they seem really great, but there's just some unintended consequences that you need to be aware of. Thanks everybody. Have a wonderful rest of your week. See you soon.